Section 6.2 is radicals and rational exponents. Starting with a vocabulary term, the nth root of a. It says if b to the n, and that's a b to the n, it's kind of hard to write. You can't really type exponents in this app, so I've got to handwrite an exponent. If b to the n is equal to a, then b is an nth root of a. That probably doesn't make a whole lot of sense. Let me give you an example. We know that 2 to the third power is equal to 8. So then what that means, it means that 2 is a third root of 8. Okay? Or we could say something like 3 to the fourth is equal to 81. That's a fact. So then 3 is a fourth root of 81. Okay, along those same lines, we could say that 5 is a third root of 125 because 5 to the third power is equal to 125. Okay, I think those make more sense as far as explaining what a root is rather than a definition, a written out word for word definition. Usually typed out definitions, especially for nth root of a, doesn't make a whole lot of sense. Hopefully these three examples kind of make it a little more clear what a root actually is. Okay? So the first thing we need to do is we need to understand how to write nth roots. So writing, let me erase that. Writing nth roots of a. Writing nth roots of a. Okay? Just like with a square root, we have this little symbol. Let me rewrite that. We have the little symbol. Okay? A goes under there, and then an n goes there. So if I want the third root, this n value right here becomes a 3. If I want the fourth root, it becomes a 4. If I want the fifth root, it becomes a 5, and so on. If I want the 100th root, then that n would be a 100. Okay, that n has a name. It's called the index. Okay? The number in the little crook of that square root symbol, or what's called the radical symbol, is called the index. Okay? The whole thing in general is called a radical, or a radical expression. Okay? For example, if I wrote this, the index is 3, what's underneath is 8, what that means is the third root, or if it's third root, we could call it the cube root of 8. Or if I wanted my index was 4 and the number underneath was 21, this would be the fourth root of 21. Okay, similarly, if we wanted have a 5 there, negative 11, this would be the fifth root of negative 11. Okay, and so on. If there's not a number here, like what we normally think of, so if we just had this, if there's not a number in this area, okay, we assume that it's a 2. Okay, it's automatically assumed that it's a 2 unless there's a number already there, like the 5. If there's not a number in that area, then we assume that it's the square root. So this is the square root or second root, square root of 25. So how does this tie in to what we did in section 6.1, which was the exponents? Well, there's a way that we can write radicals using rational exponents. Rational exponents. Whenever you see the word rational, so this 5-letter word ratio starts off rational. Ratio, how we write ratios, if you remember back to 6th grade math, 7th grade math, 8th grade, pre-al, whatever, we usually write ratios with fractions. Okay, so anytime you see the word rational, really what that means is fractions. Okay, so we're writing radicals, the square root symbol, or cube root, or fourth root, or whatever, using a ratio or a fraction. Here's how we do it. So if we want the nth root of a, so it doesn't matter what the index is. It could be square root, could be cube root, fifth root, 100th root, whatever. Okay? How we turn this into a rational exponent. The number underneath becomes your base. Okay? and then we need to write a fraction. Now, if we want the square root, this number right here becomes the denominator of your fractional exponent, and then a 1 goes on top. Okay, so a to the 1 over n is equal to the nth root of a. Let me give you another example. If I wanted the square root of 16, that would be 16 to the 1/2 power. Or if I wanted the cube root of 8, this would be 8 to the 1/3 power. Okay, a couple of examples there. So the number, let me change colors here again. The number in the crook, the index, becomes the denominator of your fraction, and if there's nothing else, then the number there is a 1. All right, let's try some examples. Directions say convert to radical form or exponential form. So if I give you something with a radical, you need to turn it into something with an exponent. If I give you something with an exponent, turn it into something with a radical. Whoops, we'll change that to black. Number 1, square root of 21. Since it's in radical form, we need to turn it into exponential form. The number here, if you don't see it, remember it's 2. So it's going to be 21. The number underneath is your base. And then the square root is the same as the 1/2 power. So 21 to the 1/2 power is your answer there for number 1. Number 2, how about the cube root of 81? Well, 81 becomes your base. This number over here becomes the denominator of your fraction, and then a 1 goes on top. So 81 to the 1/3 power. Number 3, how about the 4th root of 37? Okay, again, the number here, actually 37 is your base, the number underneath is your base. We're writing it with a fractional exponent, so the number in the index is your denominator of your fraction, and then a 1 goes on top, so 37 to the 1/4 power. Number 4, let's try another one. Let's go the other way. I'm going to give you something in exponential form. You need to put it into radical form. So negative 343 to the 1/3 power. Okay, just remember, the base is what goes underneath the radical, negative 343. The number here becomes your index, 3, and since there's a 1 up top, we don't need to worry about that. The cube root of negative 343 is your answer there for number 4. Number 5, negative 7.8 to the 1/5 power. That's a 5. Let's try that again. 1/5 power. Okay, so start with your radical symbol. This number becomes your index, so that's a 5 there. This number right here, the base of your exponent becomes the number underneath. So the 5th root of negative 7.8. And then lastly, number 6, 121 to the 1/2 power. Since it's the 1/2 power, that's kind of like square root. We don't really need to put anything there, because if there's nothing here, like if we leave it blank, we assume that it is the square root. Okay, so all we need to do is put a 121 underneath, and then that would be your answer, the square root of 121. All right, hopefully those make sense. Let's go ahead and move on. New question: how many roots does a number have? So we're talking about the nth root of a, which again we could rewrite that with an exponent, a to the 1 over n power. Okay, it really depends on two things. It depends on the number in the index, that nth root, whether it's cube root, square root, 4th root, 5th root, whatever, and it also depends on the number underneath. Okay, so what I'm going to do, I'm going to draw a table here. It's going to have 3 rows and kind of 2 main columns. Okay, so it depends on your index. So n is even or n is odd. And then I also said it depends on the number underneath. So if I say it's less than 0, meaning negative, it could be equal to 0, or it could be greater than 0. Okay, so really those are we've got 6 outcomes possible, 6 possible answers here. We'll start with the even column here. If n is even, so if I tried to type in the square root of negative 4, okay, if you try typing in the square root of negative 4 in your calculator, you're going to get an error. The reason why, there's not a number where if you multiply it by itself, you're going to get negative 4. because if you do positive 4 times positive 4, that leaves you with positive 2 and positive 2, that gives you positive 4. If you use negative 2 and negative 2, you get positive 4 again. The only way you can get negative 4 is positive 2 times negative 2, which those aren't the same numbers, so it wouldn't be a square root. So when you've got a negative number underneath and a even number in your index, your answer here is 0 real roots. There aren't any real answers to that problem. There aren't any real square roots of negative 4. Now, as we get into Algebra 2, we'll actually find out that there are square roots, but they aren't real, and they're what's called imaginary. And if you take Algebra 2, we'll definitely get into that. Okay, so let's move on to n even a equals 0. So we're talking about the square root of 0. If you type square root of 0 into your calculator, you're going to get just one answer, and it's 0. Okay, so this is equal to 0, which means there is one real root. Okay, the quantity is 1. The actual answer then is 0. Okay, so if it's asking how many, then the answer is 1. If it's actually looking for the root, then the answer is 0. Okay, so now if we move on to a is greater than 0, so now we're looking at like the square root of positive 4. If we think about what number times itself gives you positive 4, there's actually two answers here. There's positive 2, because 2 times 2 is 4, but then we also talked about it earlier, negative 2 is also an answer. Negative 2 times negative 2 is also positive 4. So if the number underneath the radical is positive, and the radical itself, the index is even, you actually have two real roots. And whether it's if it's a square root or fourth root or sixth root, the answer is always going to be the same. The numbers themselves are pretty much going to be the same. The only difference is one's positive and one's negative. So if you really wanted to shorthand this, and I'll erase some of this, you could write this as plus or minus 2, and that would kind of save you some writing as far as having to write out both numbers. You could just write plus or minus, and that makes the statement that, yes, there's a positive one and a negative one, and I'm just being lazy and I don't want to write positive 2 and then negative 2. You can write plus or minus and then a 2. Those are definitely the harder of the three. If the index, the n value is odd, so let's go back here to the odd side. Let's talk about the cube root of negative 8. There is a number that if you multiply it by itself 3 times gives you negative 8, and the answer is negative 2. Negative 2 times negative 2 is positive 4 times negative 2 again gives you negative 8. So if the index is odd and the number underneath is negative, your answer here is one real root as far as the quantity of the number of answers. The actual answer itself depends on what this number here is. But if this is odd and that's negative, your answer then is one real root. Okay, let's move on to the cube root of 0. Again, there's only one number that multiplies by itself 3 times to get 0, and that answer is 0. So how many real roots are there? How many real answers are there? Again, just one real root. Okay, moving on, the cube root of positive 8. Only one number here that multiplies by itself 3 times to get positive 8, and that answer is 2. 2 times 2 is 4 times 2 gives me 8. I can't use negative 2 because that would give me negative 8. So really, again, just one real root. It's really easy if your index is odd, because the answer is always going to be one real root. You just have to find it. If you need help typing the cube root into the calculators, because calculators can do cube roots, please see me, and I will show you how. Otherwise, you can certainly Google it. There are instructions available online. Okay, so let's use this table to do some examples. So the directions will say, find the indicated, that's the word indicated, real nth roots of A. Find the indicated real roots of A. So what the directions are asking for, it's not asking for how many there are. Your answer is going to be something like this one, plus or minus 2, or positive 2, or 0, or something like that. Okay, we're not looking for how many, we're actually looking for what they are. Okay, so number 1, we're going to say n is equal to 3, and a is equal to negative 64. Okay, again, if we were going to write this out, we're thinking nth root of a. Okay, so this becomes the cube root of negative 64. If you think about this, there's only one number. Since it's odd and negative, we're in this box right here, odd and negative. There's only one answer. There's only one number that if you multiply that number by itself 3 times, you get negative 64. And that answer is negative 4. So negative 4 is your answer for number 1. Number 2, let's go with n equals 2 and a equals 81. Okay, so now we're in even and positive. So that's this box down here. Okay, so we're looking for the square root, and if it's square, you don't need to write anything in that index, square root of 81. Since we have 2 real roots, we know it's going to be positive and negative, and then we just need to think what number times itself gives you 81, and that answer would be 9. Okay, let's try another one here. Number 3. Let's go with n equals 3, a equals positive 27. Okay, so we're talking cube root of positive 27. We're in this box here. N is odd, a is positive. One real answer. What number times itself 3 times gives you 27? That answer would be 3. And then finally number 4. N equals 4, a equals 16. So now we're in the 4th root of positive 16. Even and positive, just like example number 2 up there. 2 answers here, plus or minus. The number times itself 4 times to get 16, that would be 2. All right, let's try some more examples, but slightly different wording. So, example, evaluate each expression. Evaluate each expression. Okay, number 1. I'm going to just straight up give you the 4th root of 81. Okay, 4th root of 81. If it just says evaluate and it doesn't have a plus or minus in front, it just wants the positive. Or if it had a negative in front of it, it would just want the negative. So we don't necessarily need to worry about plus or minus here, even though it is even and positive. We just need to figure out the 4th root of 81. Number times itself 4 times to get 81. That would be 3, because 3 times 3 times 3 times 3 would be 81. Now, like I was saying, if there's not a sign in front, we don't need to put a sign in front. But if there is a sign in front, like negative 4th root of 81, now we need the negative sign in front. But the 4th root of 81 is still 3. So the answer for number 2 then would be negative 3. Number 3, how about 25 to the 1/2 power? Okay, so now we're going back to those exponents. Remember, with fractional exponents, this number, the bottom number, is your index. It's the root we're looking for. If it's a 2, we don't really need to write it. The base goes underneath. So the square root of 25, again, if it doesn't have a sign in front, we don't need to worry about putting a sign in front. 5 is going to be your answer there for number 3. And then lastly, number 4, negative 25 to the 1/2 power. It's important that negative 25 is in parentheses. Okay, so again, we'll turn this into radical form. Negative 25 is my base, so that goes underneath. So now we're looking for the square root of negative 25. This goes back to square root, negative number, no real roots. So if you get a problem like this, your answer here is not possible. There is no answer. There's no real answer that gives that. There's no real number that would, if you take it times itself, you get negative 25. What I want to talk about next is other rational exponents. I've got other in quotes because it's really not other, but it's an extension of these rational or fractional exponents where the numerator isn't 1. Okay, so in everything we've talked about so far, the numerator has been 1. But now when we get into this other category, we're going to talk about when the exponent, especially the numerator in that exponent, isn't 1. Okay, so the rule goes like this. If you have a to the m over n power, so m is not going to be 1. Okay, how this breaks down, you can break this down into two separate things. You can call this the nth root of a to the m power, because remember the nth root, or the 1 over n power is the nth root, or you can call this the nth root of a to the m power. Okay, these two are the same thing. I don't want to say that you have to use one or do one and then get to the other. They are the same thing. Okay, so it's truly a personal preference on how you want to do this. For example, if you had 27 to the 2/3 power, you could break this down into one of two ways. You could call this 27 to the 1/3 power, which then would break down into the cube root of 20, let's try that again, 27, cube root of 27, and then raise that to the second power. Or you could call this 27 squared to the 1/3 power, which is the same thing as the cube root of 27 squared. Okay, it's either one or the other. You don't have to do both. In the end, you would get the same thing, regardless of which option you choose. Okay, so we're gonna practice a few of these. Hopefully, we can start to figure things out as we go along. Okay, so the directions are going to be pretty simple. Evaluate. Okay, so we're going to evaluate. Number 1, let's go with 16 to the 3/4 power. Okay, so we've got two different ways. My personal preference is this one, where we take the smaller, we get smaller with the root, and then we get a little bigger with the power, rather than get really big with the power and then get small again with the root. Okay, so I'm going to break this down into the 4th root of 16, and then we'll raise that to the 3rd power. 4th root of 16, what number times itself? 4 times gives you 16. The answer there is 2, and that is to the 3rd power then. 2 to the 3rd power then would be 8. So 16 to the 3/4 power is equal to 8. Number 2, 27 to the 4/3 power. We had 2/3 power, so now we're going to go to 4/3 power. Again, this bottom number, the denominator of your fraction, becomes the root, 3rd root of your base, which is 27, and then we will raise it at the very end to the 4th power, or the numerator power. So the cube root of 27, what number times itself 3 times gives you 27? That would be 3. So then we'll have 3 to the 4th power. 3 times 3 is 9. So we can write it out this way. 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. So there's a quick way to do something to the 4th power. Okay? I'm going to erase this just so I can have some more room. And let's try another one. Number 3. 243 to the 2/5 power. Now, I'm not expecting you to know the 5th power or 5th roots of anything. In class, I will have a little half sheet for you that will make things a lot simpler, I hope, that will kind of allow you to figure out 5th roots, 3rd roots, 4th roots very quickly, very easily. So don't get stressed that you don't know what the 5th root of 243 is. In class, I will have something to hopefully alleviate that stress. So remember, the bottom number is your root or your index. The base becomes your number underneath, and then this numerator becomes the power on the outside. 5th root of 243, I will tell you right now that that is 3, and then that's not going to be 3 to the 3rd, that's going to be 3 to the 2nd power. 3 to the 2nd power is 9. Let's try one more real quick here. Number 416 to the 3/2 power. Okay, 16 to the 3/2 power. Again, we got a radical. The denominator is your index, and if it's 2, we don't need to write it. The base goes underneath, so 16 goes underneath the radical, and then the numerator, 3, becomes the exponent at the end. Square root of 16 is 4. 4 times 4 is 16, and then we'll have to cube that at the end. 4 times 4 times 4 is 64.